And of course, we are going to graph everything here. Well, they have the graph in part B anyway. So if you had cos x minus pi over 6, does it make sense that that pi over 6 is inside our function? So this will be horizontal translation, left or right. Remember, everything inside the function is opposite. So that minus pi over 6 would be a horizontal translation, pi over 6 to the right. So for graphing this, for graphing horizontal translations, we're going to graph the graph of cos first. Cos has an amplitude of 1, so we'll go maximum of 1, minimum of negative 1. The period is 2 pi, so we're going to mark 2 pi and divide it into 4 equal sections. And a cos graph starts at a maximum. I'm just going to draw the cos graph with a dotted line so it's easier to visualize later. So there's our cos graph. It would keep on going forever and ever. Now we want to shift this cos graph pi over 6 to the right. Which, if we chose the 5 points on the cos graph, the original ones, and had to add pi over 6 to each of the x-coordinates, some of the mental math is going to be kind of annoying. So again, we're going to notice a shortcut for this. The shortcut that we're going to notice for graphing this is if we can mark on here where pi over 6 is. We're going to use our pi plate. Think on here. Okay, pi over 6 is 30 degrees. On my scale here, I have the axes family, which is 90 degrees. From 0 to pi over 2 is 90 degrees. I need to label pi over 6, which is 30 degrees. Can you see that that would be 1/3 of the way between 0 and pi over 2? So on my x-axis, I'm going to estimate 1/3, and I am going to label pi over 6. And I'm going to do that estimate of 1/3 for each of these. Shift this one over 1/3, this one shift over pi over 6, shift that one over pi over 6, and that one. And then each of the 5 points that were part of my axes family, I now just shift them over this distance of pi over 6 to the right. And you don't even have to worry about labeling those. As long as you've labeled the first one at pi over 6, the other ones are obvious from there, which will save you some mental math. Where does a cos graph? Now we just take these points, draw a nice curve in between each of them, and it continues on forever. Now, we're going to reread the question and make sure we answered it correctly. That's an important skill once you're done a question to reread things. Okay? Determine the phase shift. Yes, we did pi over 6 to the right. Sketch the graphs of cos and y equals cos x minus pi over 6. Now, what the textbook has that's different than what we did is this part. They said between 0 and 2 pi, and we put arrowheads on to say that it kept on going forever. Okay? Now, on your quizzes and tests and exam, most likely I'm going to say, instead of this, I'm going to say for at least one period, which means you can draw it, put arrowheads on to say that it continues on forever. Technically, when they write 0 less than or equal to x less than or equal to 2 pi, I would lose a half a mark on my question because I graphed too much. I should take out an eraser, erase everything left of 0, erase everything left of 2 pi, and this is how I should end it without arrowheads on it. Just endpoints here here and stop. Okay? Sometimes the domain that the textbooks give you is really annoying. So I'm going to say if they give you a domain and you reread it, I give you permission to put a line through the domain and write at least one period. I do not mind. Sometimes the domain they will give you is really annoying. So if you draw at least one period, that'll be the same that I'll ask on your quizzes and tests. So then you'll be fine. So you can circle 3, E, and F. And this is where we'll stop for today. Thank you.
It's funny, I have so much trouble remembering my unit circle. I can remember it.
Yeah.
I have a lot of shortcuts in my memory problems. But I learned so much with science.